So hello everyone, welcome to the project. Here we are going to make a caterpillar game. We are using Python and Turtle to build it. So our two requirements will be a Python. You can just use any Python compiler like VS Code, Atom, Jupyter, and even work with the terminal. And some library you need to import, and that is the Turtle. So Turtle is really a very fantastic library that is built worked with Python. We will learn about it in this project. Now let's start at how we are going to proceed. Our first step will be to create a caterpillar and then create a leaf. So we will be making a two structure, design two. The first will be a caterpillar and then second we are going to design a leaf. After this, we are going to design so many other variables like speed, size of the caterpillar, how we are going to make the score, the start game. Then we will go move on to make our caterpillar move forward, design some more steps like how the caterpillar is going to change the direction, how its speed will increase with the eating leaves. Like according to a traditional game, caterpillar start eating more and more leaves. The speed of the caterpillar also increases, which makes it a bit difficult for us to play the game, but that also makes the game interesting. So with size and speed increases, the difficulty level of the leaves also increases. Now coming to the next thing, that we have to decide so many things. If a leaf is not eaten by the caterpillar or eaten by the caterpillar. If eaten by the caterpillar, then we need to change the location of the leaf and taking care that it is a random location. Also caterpillar is not out of the screen, means if caterpillar is out of the screen and then it is coming back, this is the violation of the game rules. We don't want to be that this may happen, because this is a game rule. So we will take care that caterpillar is not out of the screen. These so many things will all be running together, and we are going to make functions to take care that no rules is broken in the game. Now the main logics behind that, we are going to make arrow keys, and to use the arrow keys we control the caterpillar. We are just going to control the direction of the caterpillar. We cannot control the speed or the movement of the caterpillar. Means user cannot decide that caterpillar should stop or move. It will just get on moving. What we are going to give to the user the control of the direction, and we will bind the keys with the game so that user can easily play with the key. Second things, the more and more the caterpillar eats, it bigger and move faster, as I have discussed earlier. So these are the important things, because on this basis only a game looks more and more interesting, since it gets more and more difficult. Now we will talk something about the turtle. So turtle is an inbuilt library of the Python. It is not coming downloaded by default, so we need to install it on our PC. Its installation part is really simple. All you need to do, open the command prompt and write there pip install turtle, and then turtle will be installed there. I have also explained in the videos that how we are going to install the turtle. Now turtle is divided into two parts. The first is the turtle screen and the second is the turtle object. So we are going to work and learn about how to work with the turtle screen, also with the turtle object. But you can consider it to be a class and its objects. Means when you create a class, all the properties are inherited by its object, and then object can just move on the screen. It can just reappear on the screen, can become invisible from the screen. So screen is just a temporary thing which will remain permanent. All the moving objects, all the moving properties will be inherited by the object. Means object, it is the object only which will change the color, which will change the locations. Also our score and text that will be displayed, like game over, what is the current score, and the updating of the score will also be formed using our objects only. So let's start building the project. It's going to be really interesting to build your own caterpillar game. So everyone, this project we are going to caterpillar, and for building a caterpillar we just need an extra library, that is the turtle. You may not have that library pre-installed. All you need to do is just open the command prompt and write there pip install turtle. So this is a turtle is a graphical library of a Python which just gives us some very powerful graphical to work with. Since we are working with a caterpillar game, we need some graphical works also, like moving the images, moving the caterpillar, and just changing the leaves, displaying the text, displaying the scores, many keyboard commands. All we need to do is just use this caterpillar game to do that. So this is a turtle library which we are going to install using pip. You can see I have already installed it, so it is shown that requirement is already satisfied. Now if you don't have that, you can just use download it using pip. So that was about how we are going to install the turtle library. Now the next thing comes, how to use this turtle library. Before going entering into the game, we just need some demonstrations or basic commands that how does the turtle work. So you can call it as a basic turtle. In this video, we are just, before starting the game, we are just going to discuss that how does the turtle works and what are some basic syntax that are used for the turtle. So all you need to do is just, you can run with go with VS Code also, you can go with Jupyter also. I'm using a command prompt to just show you how everything works, because in this I can directly explain you and without using just run as a terminal time button, which just takes some time. In terminal I can just directly run my command. So here we are going to practice some of the required or basic commands that the turtle use, and how actually does turtle look like. All I need to do is first import turtle. I am going to import turtle and just use a variable t for turtle. Retained successfully means no error was shown to us. It means that turtle was successfully imported as a t. Now first we will discuss about the goto command. So this goto command is basically a command in which consider this is your turtle window, turtle graphical window. Now if this is your cursor and you want that this cursor should go from here to here, by default your cursor will be at the center. If you want that this cursor should go and point to this pip, it will take the shortest route. Instead of going from here to here, it will just directly from E to go to the P and stops there, the coordinate that I am going to give. So it is divided into 4 quadrants, that is, this is 0 comma 0, this is for -1 0 quadrant, this is positive for minus minus quadrant, and this is for plus minus quadrant. So this was for minus minus quadrant, and this is for plus minus quadrant. Now the 4 quadrants are there. We can just give a coordinate for any one of these quadrants which will point, and our center turtle, that will be a cursor, it will directly go to that particular point. It stops till there. Now there are very different kinds of activities also possible, functions also possible that we can use, like giving them color, just slowing down the speed, and many more. So we are going to discuss that, but first I am going to give you that what does goto does. So it actually takes your cursor from a default center position 0 0 comma position till where you have given the coordinate. For example, if I give a coordinate from -97 and -139, it will take my cursor to that particular position. So you can see this is a minus minus quadrant, the fourth quadrant. This is the center 0 comma 0. So it just went to a -197 -137 9 position where we have actually given that. Now if I again give it, for example, t.goto, and try to send it to the first quadrant, is 100 comma 100 plus plus quadrant, see it has reached. From here it went to this path. Now this is, it uses a shortest path. For example, it will not go from here to here, but use the shortest path, that is directly from this point to this point. So this was about how does the goto function works. Now if you want to go back here in just 2 steps, for example, not using the shortest path but using a triangle path, that from here to here, all we need to do just give back the command, that is 100 comma 100, but instead of that we will just use it to reach here. For example, first we will keep our y coordinate as same. Now we want to go back to the -97 and we are at 100, so I am going to just give a -197 and keep it as 100. So it has just came back here. After this I am going to just give here t goto and keep this as -197. Just give another change the y coordinate, and that will be -239. So it will just go perpendicularly down. You can see we get a great triangle here. This is our triangle that we wanted. Now this was about the goto command. There is one more command. If I wanted to go from this point to this point and start my writing from here, means I want to work down here. I have worked at the center and I want to work here or here. But if I try to go to this position, maybe this may be a 100 comma -200 position, and if I try to go 100 comma -200, but the problem is that I want to start my new work from here, but this line is continuously following me. I don't want this line to be there. All I need to do, just t dot use a function pan up. So what this pan up function do, actually it takes where your pen was, sorry, if your pen is here, means your pen is working at this position. Now you want that your pen should be out, does not touch the paper or the window, and then get back to the position that we are giving. So we will use a pan up function. Now if I give a new coordinate, that is t dot go to, so you can see this is 100 comma -200, means fourth quadrant. And now if I will go to the second quadrant, that is -120 comma, let's take +100. So it will just get back to the opposite quadrant, but this time it will not draw the line here. Try to open one. So this was about the pan up function that usually we use it. I'm going to show you directly. For example, I will copy this. And if I use run the pan up function, means my cursor is not touching the graphical interface, but it will go directly to that particular point without touching it. First we will go to some position, for example t dot go to 10 comma, there we go. Okay, let's go to this point. So we have come here. Now I will call the pan up function dot pan up. Now after again I will go to some new position, that is t dot go to 1 comma 2. So this time if you notice here that this was actually a near position, so we were not able to identify that it has reached or not because it has started from 0 comma 0. Now if I try to go to t dot go to it, so this is opposite of that coordinate. This time you can see actually this 1 comma 2 was very near to 0 comma 0, so it would be difficult to identify. But this time you can see that we have reached a position, but we were not having any line here, means the continuous line was broken. Now we are at a new position. Now all I need to do, if I want to start here, I will just do a pen down. So this will again start drawing anything on the window. If I go from 100 comma 100, I will go to 50 comma -50. So you can see I have a new line here created here. So this is a use of the pen down and pen up function. Now we will learn some more functions. After this, I can also give color to my pen. Well, if I just give a color, and let's take my color would be yellow. Now if I try to go to a new position, let's make comma 50. This time you can see there is a yellow line visible here. you would be able to see this is yellow. Let's so it will draw a yellow color line if you wanted to draw. Now I can also just determine the size, that to what extent or how much thickness should it be. So if I make the pen size to be 25, now try to draw a line 150. So you can see that the thickness of the pen has tremendously increased. Our yellow line, it was previously so thick, but now it is of 150. Now there are several new things. Like pen size. We have studied about color. We have also studied about pen up, pen down. Now the next thing that comes here, let's first change the pen size. Dot pen size, let's make it 5 because that was really very large. Okay, so now change the speed, t dot speed. We are actually speeding up because 50 is really a great speed. Now if I am at 50 comma 150, the longest distance that I want is, let's take, we will go to minus 200 or minus 2. Now if I run it, so you would not be able to notice it, but this is the way actually we control the speed, that how our speed is going. Try to show it back. Now it will be visible. If I write again, but just 200, try to run it. So you can see this in a blinking of eyes, before blinking of eyes, it has reached there. So this is a great speed that we are using. Also, I can change the background color of the screen. For example, t dot get screen. This will function changes the background color, that is BG color. You can give any color of your choice. I am giving blue. You can see our color is now blue, and you can just give any color that you wanted. So this was about some basic syntax that we actually used, that how we can change the color. Now we can control it without giving coordinates. For example, if I write a syntax t dot forward, with t dot forward, if I wanted to go forward just 300 units as went, we will change the speed, make speed to be 5, same as the pens. I will again use that is dot forward, but instead of forward we will just give another syntax like left. So dot right 300. So 300 maybe is coming back to forward only, and this time I am going to give a 130. In when 130, let's change speed to be lesser than 5, so that it makes very easy for us. This time we are going to just use a forward unit. So this is now you would be easily able to notice that it's going forward 100 direction. Now let's go right. See, with right it just goes changes its direction. Now if I try to again give a right, notice that it has again changed the direction. Now this time we will just give a forward direction. It has went forward in this particular direction. So with right or left we can control the direction, and with forward we go where we actually want it. So this is how it works. You would have able to understand that how we have used forward, we have used all these functions we are going to be using in our function, that is the caterpillar game, to design the caterpillar, because we have to control so many things here. For example, our caterpillar, our leaf that the caterpillar will be able to will be eating, our text, our score, and the basic keyboard commands, because we will not be controlling it by just writing the syntax like move forward, move left. All we are just going to use the keyboard keys, so we need to bind our keys with the function. Let's start building the game. Welcome to this video. We have discussed about the basic turtle, that how we are going to use the turtle library, their installation parts, some basic ones, go to and bg color, pen down, pen up. So that was about the turtle. Now in this video we are just going to start building our game. So let's start importing by turtle library. All we are going to do is just import turtle as we have done in the last library, st. We have imported the turtle library. Now we are going to just import a random function. We will be needed it to just randomize the leaf, that where the leaves will be there. So this was about import. Now next thing comes, we need to just give a bg color, that is the background color, to our window. So let's give it, so t dot bg color. Here comes the color, that is here. So this will be the background color of our window that we will be using. Now we need to define so many variables here. Like our first variable will be the caterpillar. Here is our caterpillar, and it will be t dot turtle. Now this is the correct way to actually define a variable. This name doesn't matter, but t is our, we have imported turtle st, and this turtle, the capital T letter, is a function which just gives this module, that is the t, and this turtle function to this variable t, to this caterpillar that we have defined. So in simple words, this caterpillar is actually having this module, and from that module it is just having this turtle function. So this turtle function will give some shapes and graphical effects to this caterpillar. Like if we want to move our caterpillar, if we want to design our caterpillar, if we want to control its speed, movement, its location, all that is possible because we are using this turtle library. And from that turtle library we have created an object. You can consider it to be a class. This caterpillar is now has all the property of an object of this turtle class. Now define another variable. So first, in caterpillar game there will be a caterpillar. That caterpillar needs something to eat, so we will be going to define that as turtle. Here we go. Now this was about the leaf. Now the next thing that we actually want is, we want some text also, like how does the text will be displayed and how different text will be visible to us. So let's start the defining the text. Our text will start by game started equals to false. After this we are going to define the text underscore turtle. Now text underscore turtle will go, can say just it will also have the turtle property. Here we go with the turtle. Now again you may be thinking that okay, leaf and caterpillar were just the shapes and the graphical effects of the games, like they will be moving, they will crawling, they will be displaying, but text will also be a graphical effect. We are using it, making it a function. It will help us to design so many things, like if you are wanted to change the parameter of the text, or you are just changing something, anything that you wanted, its location, its color, so then also we need to import the turtle function. Then it is easier to go, instead of using the text function from the Python, better to use the inbuilt text function of the turtle, because it gives us so many facilities to us. After this, our next thing is left, that we should be able to watch the score. So similar is from the text is the score also. Score will be in a textual form, or you can say numerical form, will be just continuously getting updated, but we are using a turtle property to make it more simpler to do, give some more effects also that we wanted to give. So in this game we have four things. The first is the caterpillar, the second is the leaf that caterpillar will eat, the third is the text that will come be visible to us like game started, game over, and the fourth is the score that will be just getting updated. So these two are just a basic commands. They will not take, they will be simpler, but caterpillar and leaf will be, and even leaf will be the most complex thing of the game. It needs a random function to be at the random location. It needs, if caterpillar has eaten it, it should be get deleted, disappeared, and a new one should come at a random position. Also its shape is, we need to design the shape because leaf shape is not available in from by default in the turtle. So we are going to design the shape of the leaf. So let's start with the caterpillar. In this function we are just going to define everything related to the caterpillar, then leaf, then text, then score. After that we will move on to the functions which will be just compiling them together. So for that we will be just caterpillar, and then we need to define its shape. Now its shape will be a square. So remember, whenever you just define or give a shape any to a variable, that is, this is our caterpillar object, so we use a shape method, and this shape method assign this particular shape to this particular object that we have actually created. So previously caterpillar does not have any shape, but now it has one, that is the square. Now we need to define the speed. So to make the game more interesting, or can say a more difficult, we just need to adjust the speed. It means we cannot just fix our speed that okay, our speed will be this. Users should just get some interest. So to do that, our game should look simpler by our speed equals to 0, means it will be very easy for the user or the one who is playing to getting started with the game. And after that he has started, he will we will just keep increasing the speed so that game would become more difficult. If it is simple from the starting to end, no one will going to play your game. After some time they will just get bored. If it is too difficult, means the speed is too high, so everyone will not be able to win. Now we cannot go with the modded, so we need to switch between the simple speed that is at the beginning and the difficult speed that is at the advanced. So as soon as the player will just keep growing the caterpillar, and our caterpillar would be increasing, its speed will also increase with time. Now we need to close this, that is panup. So remember that panup is a function with which you can just stop making your caterpillar. Means if you are switching from caterpillar to leaf, you will not draw a line. Otherwise, if in the graphical window you are having a caterpillar, you have eaten a new leaf, and then a new leaf should come on the graphical window. If a new leaf have came in the graphical window, for example this is our graphical window, if a new leaf has appeared on the graphical window and you have not done this pan up, so a line will be drawn from your caterpillar to the leaf. So that will just that will not look so good. It will be irritating that new lines will keep coming up. So after every shape we need to do the pan up so that it may not increase this. So we are going to hide turtle. Now before hiding the turtle, okay, so we will go with the leaf. I wanted to show you, but I will show you those functions that is really important to understand that concept after completing this. So now we are going to define the leaf shape. Now here we have given a shape that is a square to our caterpillar, but leaf shape is not there, no such shape is there in the turtle library. If you would just write there leaf, it will not come. So a leaf is actually, we need to design that particular shape. So you can say a leaf to be a hexagon in which both the ends of the hexagons are bit small. Let's build it first. So here we are going to give the coordinates, that is 0, 0, 20, what it will do, these are two coordinates or 2 points. You can consider it to be a line, a straight line, but instead of considering it to be a straight line, you can just consider it to be a curve, like one curve goes from here and the another curve goes from here, just like a circle, but not a proper circle, a bit oval shape. So this is like this. Now we want that for our leaf there should be two more coordinates to be here and to be here, that it may give a rhombus type shape. But the thing is that whenever we use that shape, the two vertices would not be visible, only two vertices would be. Then we will get some leaf shape. So we are going to design our own shape. I have taken two coordinates. Now I want to keep my limit to be between 0 to 20 to design other vertices. So here I go. I will be first making a coordinate that is 14,2, and now opposite to coordinate, opposite to this one would be 2,14. So here comes the 2,14. Now these two vertices will be just opposite to each other, but they will just give a smooth curve effect instead of you can consider a vertex. There will be some curved effect, so vertex will not be visible to us, but that curved effect is possible by just adding two small semicircles. For those semicircles I am giving two coordinates here. This was 14,2. Next comes the 18,6. Here also we need to add just the opposite of this, comma 8. Okay, so here we have done with our leaf shape. Now we need to register this shape. You cannot use directly to this because you have created your own shape. So I need to give it a name. So my name will be the leaf. You can give any name to it, like cake, road, anything that you want, but I am giving this name. Now this is leaf shape and the shape that I have defined. So now my shape is actually registered. Now I am going to just use leaf dot shape. This time I am assigning my variable, that is the leaf, this particular shape that I have made, that is leaf. So don't get confused that what we have done in these two lines and what has actually happened in these two lines. So basically we have designed our own shapes, that's why these two extra lines were added, and then these two are similar to the above one. So here we go, leaf dot shape. Now we need to just do again a leaf dot pen up, that no more extra lines should be there, because if you don't do the pen up they will just drawn together. Now here we go, hide turtle. Actually these functions make them invisible. Now we are going to leave. We will define the speed data because we need to increase the speed also. Let's see, we have built till now. We have designed the caterpillar and we have designed the leaf. After this, two more things are left, that is the game started, and for those game started we are going to define the text in the turtle, that the variable we have actually taken text turtle. The next thing, we need to define the score also. So we also need to use many variables there, like that speed also we need to define that at which speed our score is getting updated, because if we are not able to manage the speed, they will be just updated very fast. Actually our caterpillar and our leaf was hidden. We will make them visible. Now it's done. Let's run it once. So actually it was getting disappeared. We need to make them different functions to be visible, but now it's currently working. I will go with completing these things, then I will show you that how actually it looks. So we were at the text dot underscore turtle. We will be just using a write function, that is text turtle dot write. This write function will give us the text that we wanted to display, and our text will be is start. So when a user will press the space, then only our game will start. So we needed to align it. Here we go, align. So we need to align it at the center because that is the most suitable thing. Now this is some extra thing, that is the designing part. Since we are using turtle and we don't know designing, so it don't looks good. So you can just choose any font here. For example, I am using my font to be Arial. Next thing, I am using the, you can say this is the font size to be 18. Now additional thing, I am just giving a bold here because light thing may not be visible clearly, and since we are writing very small text, it should be visible to us using bold. Here we go, text underscore turtle, and we are going to hide this. So hide turtle. After hiding this, our text part is complete. Now we are left with the score turtle. Then I'm going to show you that how our display is made. Hide turtle, we are going to hide it. We are going to update the score using the function. So here I am just defining my variable, and the next thing that I am going to define is the speed, that it should be updated a bit slower than the other one. The reason is that if it is updated too fastly, we are not able to see it. Now we have defined all the functions or the variables that we would be needed, from libraries to the caterpillars, leaves, their basic designs. In the next video, I'm going to show you how we are going to implement them. So just keep watching the video. The thing is going to be interesting. Thank you. Hello everyone. In the last lecture, we have defined all the prerequisites that we would be needed with variable name. Now one thing I have told you, that I will show you everything that the turtle we have designed, but before first we will complete it. Now this is the time to look at the window. If you try to run it, go here, it will be just visible for a few seconds and then disappear. The reason is that we need to give it a main loop function. Like if you know about the tkinter, we used to give there a main loop function so that it may keep there everything as it is. It means that this loop will just go on an infinite cycle until you have not used the exit or quit function, that is the cross button present over the window. So we are not going to use a main loop. I don't want to close it again and again. So I am going to use import time. So import time sti. Now we are just going to give ti dot sleep, let's say for after 5 seconds. So remember, sleep function uses parameter always in second, and many other functions just take parameters in millisecond. So just take care that which parameter they are asking about the variables. If you have given it here 3000 seconds, then you will not be able to understand that why your key window is not getting in a sleep mode. Let's run it. So it will be visible as for a few seconds, then it will just disappear automatically. So whatever things we have hidden, just check them one by one. First I am going to show you the caterpillar that I have what we have designed. So here is this square variable will be our caterpillar. Now we are just going to make check the leaf that we have actually designed. So make here in this leaf dot move it this hide turtle, then run it. So this is our leaf structure that I was talking about. This leaf structure, okay, let's make it to be 25 seconds. So this leaf structure, that is what I was talking about. Here your leaf is at 0,0 and this is our 20,2. Now this circle curve is actually a two coordinates, made up of two coordinates. The first coordinate is before starting this circle, and the second coordinate is at the starting of the circle. And these two coordinates are opposite to each other. If this is 6,14, then this is 14,6, and if this is 2,18, then that is 18,2. Now this is not actually a curve. Here a small dimension is there, edge is there, but that is too small to be visible. So we are thinking that okay, this is a type of a curve, but this is a hexagon where this edge is completely so small that it appears to be a curve. This shape is actually what we wanted to decide and what we have decided. made and designed. We have also registered it. Now I'm going to close it, now making it back to 5 seconds. Now the last thing was Score Turtle. You can easily see the space to start the beginning only. So here we go with the Score Turtle. Going to save this. Currently we have not given anything because we are going to give this at the function. We just got a cursor here and nothing. So these were the variables that we have actually made. Now coming to the functions part, the adding functionalities here. So let's start. Our first function will be check whether our caterpillar is outside the window or not. Means if your caterpillar touched the window or went out of the screen, means the game is over. So with that function or with that parameter, the input that we are going to get, like is caterpillar inside the window or not, or outside the window or not, we are going to design rest of the function, because from there we are going to do start our beginning part. Now here we go with the outside window. We need to define every wall of the screen. So this will be the parameter for the left wall. Now next parameter for the right wall. Now after this comes the top wall. Next comes the bottom wall. Okay, so these are the 4 walls that we are just comparing. Means we need to compare with every wall about the location of the caterpillar, that if caterpillar is outside of these boundaries, means our caterpillar is our game is just over and our caterpillar went out of the boundary. We need to take care that it don't go out of the boundary. So first the left wall. So left wall is actually the left side of the window, and remember our 0,0 by default starts from the middle center. So left part will be in a negative direction and right wall will be in a positive x direction. Left wall is nothing but a t dot window, and you can say t dot window. But the thing is that we are just having our 0,0 at the center, and this t dot window width is giving the window width of complete windows. If I make it divisible by 2, it means now I am having a 2 window, that is one in the left side and the other one in the right side. Just the only thing is that this left window should have a negative sign here. It means this left window should have a negative sign here. So now it denotes the left side of the window. Means this is the coordinate of the exact coordinate of the left one. So instead of calculating it or defining it from the beginning, we are just using a function that is the window width, which automatically gives us the width of that window that we have designed. Now similar for the right one, that is the t dot window width, now divided by 2, so to get the half part, and it is in the positive x direction. Here we get our positive x direction. Now comes the top wall. So we go with the t dot window height. Previously we were using width, this time we will be using height. Now remember, top wall means the upside wall, that is the positive y direction, so we would not be needed the negative sign. Coming to the bottom wall, again this the negative direction of the y axis, so our code will be the same, just we will be using window height and divided by 2. So these are the coordinates or the locations of all the boundaries that we actually have. We will be using them to compare the present condition of the caterpillar, the present coordinates of the caterpillar, and decide whether the caterpillar is in the screen or outside the screen. Now we go on, we will define a variable. Our variable will be x coordinate and y coordinate. Now this xy coordinate will be using the caterpillar, that is we have earlier defined here. When you are defining functions like you are using turtle or tkinter, and you are having some variables that is caterpillar or leaf, you don't need to give them as a parameter because they are automatically designed. The computer gets them in a runtime only, since turtle and tkinter are about the runtime libraries, so we don't need to give them as a parameter. They are identified on a runtime basis. Now I am using to get the function position function. So this position function actually helps everything out. because wherever my caterpillar would be, it will just update these variables and give me the particular location. Now, means if my caterpillar is at the center, it is 0 comma 0, and if it is at somewhere 200 comma 200, this xy coordinates will actually give them. So from here our work is very simpler, because we don't need to just stick on checking where our caterpillar would be and calculating the coordinates. It directly gives us. So what I am going to do here, I am going to compare this x coordinate with both the walls and y coordinates with what the top and bottom wall. Here x coordinate will be for left and right wall. All we are going to do is x, if it is smaller than left wall, then we will be using, or y, if it is smaller than the top wall, sorry, bottom wall, because we are going downside. So if means if this is minus 29 and bottom wall is at minus 25, so minus 29 will be technically smaller than the bottom wall. So yes, our 29 is greater digit, but we are just taking it with the negative sign. That's why we have taken the smaller sign here. Now similar for the again, x is greater than. This time I am having a positive sign. So positive sign means I can use a greater than function because I am going more than that x coordinate axis. And comes for the y, greater than top wall. Okay, so don't use AND function here. If you would be using AND, it means that your caterpillar should be has a coordinate that is greater than x and greater than y. It means it should be at a diagonal position of the window. I will show you that also. Let's complete it. Return outside. So outside, this outside is actually comparing the two logics with a OR operator. So definitely it is going to give us a boolean value of true and false. That was about comparing function. Now let's take why we are not using AND here and why we have used OR here. If I run back my function, you can see here this is the y coordinate, x coordinate, minus x coordinate, but smaller than the y coordinate. So if it is here, it will definitely, this AND condition will not going to be true, even this x coordinate exceeds. But AND condition will only get true if our caterpillar go diagonally in this direction, out here or out here. If it goes diagonally, then these conditions can become true. And if we are given all the AND conditions, that they are not going to be true every time, or you can say with any condition. So yes, it is a possibility that for one time this AND condition may become true. But if you are using an AND operator instead of OR for whole, then there is never a chance that they will become true. So it means wherever your caterpillar goes, you will get a false statement. So take care of the OR function. Now coming to the next thing, we are going to define the leaf. Now we have the caterpillar. Before defining the movements of the caterpillar, we are just going to define the leaf. So we are going to define leaf. Now here we go. Where will our leaf location will be? So instead of place, we can use location. Now leaf LOC, that is location. So first, wherever my leaf would be, I will hide it. I am hiding it because I don't want that there would be two leaves at the same instance of graphical window. So I will be using the function hide turtle. So here it will actually hide my turtle that it will hide, this hide turtle will actually hide my leaf that I was having. Now from now, wherever my leaf would be, it is just disappeared, means we are not bothered about it. Now we need to reassign the leaf location, means we need to make new x coordinate for the leaf, and then we are going to make new y coordinate for the leaf dot set y. And after doing this, we are going to show it back. So turtle, okay. So first we have hide the leaf object. Now our leaf object will become visible. The only thing is that we have rechanged the location of the leaf. Okay, if you would be not using a leaf.hide turtle and leaf.show turtle, what will happen when you will just reassign the location of the leaf? For example, if you have done this only, that leaf.setx, leaf.set y. So your leaf would be just going from one direction to other direction, and your caterpillar and the game would be watching it that okay, your leaf is currently moving. We don't want that movement to be visible to the user. That's why first we are hiding it, changing the movements, changing the coordinates, means moving the leaf, and then again showing it back. So in graphic, in turtle, everything is visible to us whether it's in moving state or not in moving state. And since if speed would be very slow, a user can easily just watch it that okay, this leaf is going from one place to another. So that would look that would not look good. That's why we are hiding it and showing the turtle. Okay, we have defined our two functions. Is one for checking whether our caterpillar is outside the window, and the other one to just change the leaf location. That whenever we want, we can just change leaf. Now, this leaf location is actually we have not given the values here. We have left that in the previous lecture. Now we are going to give the value to our leaf, and this is just a random value. You don't want that your x coordinate, y coordinate should be in a pattern so that anyone could identify that okay, the first one will be at the first coordinate, the second one in the second, and the third one in the third coordinate. So we want a random value for x coordinate and y coordinate. All we have imported one library at the beginning is random as rd. We are just going to use this library to assign the x coordinate. Now we are going to just use rd random, and here we need to give a random parameter, means our range, from where our range should. So you can use these two variables like we have given here, left wall and right wall. But remember, in using this there is a problem. Technically you are right that okay, you have a parameter from left wall to right wall to place your leaf from this towards here. But the thing is, if your leaf is just at this point or at the center, you can say just over here at the center of the function, somewhere touching the boundaries, it will not look good. It will be difficult for caterpillar to go there and touch the boundary. So we will be take care that they will not come to the boundaries, touch the boundaries. So what we are going to do, we are just going to copy this, paste it here, is minus the window. So first we will just give it directly, then we are going to modify it. Now our next one comes, this was for the minus and this will be for the positive. These are actually our values where we will be putting our leaf or assign the leaf value wherever we want. So we will go copy this again, call the same function rd random and range. Here we are just taking rand. Now we are going to just put it again, value here the negative height, and this one is for the positive. So these are the values that we have actually given, and it will be going to these functions. They will be just picking up any random value from this and use it as for the leaf. Now here we are done with the leaf. This time we are going to make a function that how our game over will work. Now we are just going to define game over. So this is just a simple function, we don't need to think much about it. In game over, what actually happens, you should not be able to see the caterpillar, you should not be able to see the leaf, because that part is over. We don't want them to be there. There is a possibility in some games we are just able to see the caterpillar and the leaf. For example, if you have played any other games about the caterpillar, it's up to you that whether you want them to be there or not. For a good finishing touch, I think that caterpillar and leaf should not be there, means they should just get disappeared. So we are not going to just make them disappear as it is. What we are going to do, just change their color. Now their color will be yellow. You know why we have taken the yellow color? The reason is we have taken the yellow color. You would go upside and check the background color. It is the same as the yellow. So if your caterpillar color is also updated to the yellow, means you will not be able to see your caterpillar. It's just invisible. It is there, but it will not be visible to you. Now, similar is for the leaf. We are just making them invisible by changing their color to the background color so that no one will able to identify, okay, there is some extra yellow color over here, because no one will able to just see there that what's there. Now, the next thing, we need to just make our pen up so that if user just try to write something there, just change the function or change the coordinates for the caterpillar, or even if leaf dot is updated, we are have a t dot penup function. Since we are not going to call those functions again, so there is no chance of that leaf or caterpillar is updated. But again, we are using this penup function that if our score is shown to us, game over text is shown to us, there will be no interference with them because they are coming from a new time. Like you are able to see the game text or game over text here. So you don't want that there should be a line from your caterpillar to your game text. So this is the reason we are using a t.penup. Always use this. Now we are using next thing, that is t.hideTurtle. After this, we are just going to t.write, and here we are just going to write the text game over. Now after with game over, we need to align it at center. You can even align it at the top. You whatever your location best matches for you. Now here is the center. Next comes the font. So here is the font. Since we have earlier used the Arial, this time also we are going to use the Arial. Okay. After Arial, we are just going to use the font size, and that will be 30. And game over is needs some bigger text, so we will be using that. Now the same thing, that the text will be in the bold. Now this was about the t.write, means our game over function is done. We have our caterpillar is now invisible, our leaf is now invisible. There is t.penup, it means no more writing things there, and t.hideTurtle, it means the window that you have created here, like t.bgcolor and all the t.turtle functions that you have called, they will all just become invisible, means you will not be able to call them again. So this is the reason that we are using here t.hideTurtle. Now this was about the game over. Now we are going to go for the next function and to display our score, because after game over we want our score to be displayed. So we need to define that. Also, while game is running, we need to take care that our score is visible to us. So we will just check for both of them that it may come up. Here we go, define display score. And after this, first we are going to score.turtle that we were previously having or assigned to be cleared. So we will use a clear function here. Next, scoreTurtle.penup means no more disturbance again from the graphical window. Now from here our works start. We are going to give the x coordinate, and in x coordinate I am just going to use this window, that is t.windowWidth, t.windowHeight given for width. So this was actually for the width, divided by 2. Now we are at the center of the location, and I want it to be somewhat downside to the game over. Even if game over comes, I want it to be downside. So I am going to clear this, means subtract it -50 units so that it may come down. Now similar for the y function that we are going to do, t.windowHeight, now divided by 2 so that it may come at the center, and now this -50 so that it may come to some bit down from the center position. Now we are going to again update our score turtle that previously we have done the pen up and clear it. Now we are going to set position of this, means reassign this function to, with the coordinates that we have taken, that is x comma y coordinate. Now we have given the x comma y coordinate. Now the thing is we need to write the score turtle. So we have set the position. Now we are going to write the function. Set position is actually the same thing like you are doing the pen down, but the thing is actually you are also updating your score turtle towards a new location. For example, you can see here we have done the leaf with the leaf, set x and set y. Here we have done them all at once only using set position, so they may come back to their original position that we have given. Now we are done with the setting the value. Next thing is about the write. So we are going to write str, and here we go the current score. So current score value is currently, we have not given the variable, but we will update that variable. And next thing, we need to use the align function. Align them to be right side, means this is the center and this is the right actually where we are aligning it. So it will be on the right side of the page or the window that you are able to see. Now we are going to give some font. So font will be Arial. We are using for all the text. With Arial, we are just going to give the 40, that is a bit large. Next comes the bold, so that it is easily visible to us. That's it. We have made the game over and the display score functions. Okay, so we up till here declared many functions like outside game over. These are the basic functions that we'll be using to build a one single function. You can call it as a main function, you can call it as an init function, you can call it as a simple start game function. So there are two ways to do that. We can write a function outside those functions and just call all these functions together, and the second one is to just make a function, call every function in that function only, and call that function again and again. If we go through that way, we can save our other code like init function we are making or main logic that we are declaring, because we can work here only. Also now we don't need this sleep function because we need to make a main loop. If your game just sleep after 5 seconds, user can not be able to play. That was just to show you because I don't want to close it again and again. So now let's start with building with the start game. So here goes our game start. Now we will be just needing a new global variable, that is the game started. You can say we have declared a variable here that was game started false, was our global variable that we have earlier here. Now we are going to use this variable. We are not using a global variable, your value will not change inside the function, and you will just use this variable till the function is running. As soon as the function is over, our value will not be able to get updated. Now second thing, if game underscore started, then we need to make done nothing. So what does this means? For example, your global game started was false. Now you have called it, and now we are going to make a value game started equals to true. So what does it will do? It will go to the global game started, fetch the variable. Now check, go through a if statement and check whether the game started is a true or false. Now if this statement is false, nothing will happen. Even if it is true, nothing, it will not go through it. Just the thing is, and after this, it will just make the variable game started is equals to true. So this is just a basic concept that how we are going to start the game, because if our game has started once, we are not just going to do anything with it. But if the game has not started, we are just going to make the value to be true. We cannot just again and again make it true. Now this was about the game started. Now we need to declare a variable, just check our score. So this will be for the score is equals to 0. Now since we are having a variable is score, we can just give this as a parameter in the display score and make it as a current score as a parameter here so that it may help us. So we are having the display score as a current score as a parameter for the display score, which will be passing from the score. So this score variable which will take care about how we are updating our score value. Next thing comes the text that we have written earlier. So if you have remembered, we have written a text underscore turtle which was displaying that space to start. It was here that we have declared. So this was the text that we were actually using. Now once the game has started, we don't want that text to be there. So text.turtle, and we are going to clear it. So here goes the clear. Now our text turtle will not be visible to us. Now coming to the new thing, how Caterpillar will move. So Caterpillar will move a particular distance that we are going to give. For example, I am going to name it as Caterpillar underscore speed, and this value will equals to be 2. So what does this means? That whenever Caterpillar will move, it will just move 2 units forward, because its speed is 2, so it will just move 2 coordinate, and we will have a forward function so that it will make the forward for Caterpillar move 2 positions forward. In the starting video, I have told you that how we are using a forward function to move our image. Now coming to the next thing, we need to just give the Caterpillar its shape, because we were just able to see the single square there. We want more than one square. So before giving to the shape, I need to declare a variable, which because our shape of the Caterpillar will also gets updated with the time. So here is the length of the Caterpillar that will just take care of what is the shape. Initially its shape will be of 3 units. Then we go with the Caterpillar length. Here again comes the 1. So this is the correct syntax to go. It means that here the shape or the length of the Caterpillar will be a 3 units that we have given, and this one is actually the initial and the ending functions which are not counted. Now coming to the next thing, our Caterpillar was not visible. We will be going to make it visible. So turtle, the reason we are just displaying our Caterpillar at the initial condition, if you go up, you can see that our Caterpillar was hidden. We don't want that to be overlapped with the text that we have written over there. We want that our Caterpillar and the leaves should be visible from in the beginning only, when game has actually started. So this is the reason we have hidden our Caterpillar and leaf also. You can see our leaf was also hidden there, and then we have shown our leaf. Now our show turtle is working. Our Caterpillar will be visible. Now next thing comes is the display score. So see, the function that we have created here, it is display score. So we are going to display the score here. We are going to call this function, and as soon as you call it, you need to pass the parameter score that we will be given. It is not of our means, it does not interfere whether our score is 0 also. It will be just visible for the user that okay, your score is 0, and if it gets updated, we will update the score. Now this was next thing comes is the leaf location. We are going to place the leaf also. We need to place it somewhere. So you can see this game start function is actually how it is calling all the different functions together, and how they are just updating different values. Now we have updated many values. We have called most of the functions. Now coming that we need to keep this game running still. Someone has pressed again a key, for example a space key to start, it will restart again. We don't want that it should happen, means the function should call itself again. What we are going to do, we are just using a while loop. This is an infinite while loop. We are going to move it forward, Caterpillar forward, and here we go with the Caterpillar. So this Caterpillar speed means that Caterpillar will move actually this much amount forward direction. Means if it is 2, it will move 2 units forward. If it is 3, it will move 3 units forward. That's up to us. We can decide that how much our Caterpillar can go on. Even you can make it 20, and just in a single move your Caterpillar will be out of the game, but we are not going to do that. Now next thing comes, this is a very interesting thing. Here we are using a distance function, caterpillar distance, and leaf. This function is actually talking about that what happens if caterpillar eats a leaf, how it's going to be this function. Actually, what does functions do? This is a caterpillar object that we have created from the turtle class. This distance is a function. This leaf is another object. So this distance function actually fetch the distance that is between this leaf and this caterpillar. And if this distance is below 20, it will become true. Now why we are taking 20? You will go upside. I have told you that we have designed our leaf that is from 0 0 to be 20 20 between this. So this is the reason that the leaf distance will be maximum 20 units, and if caterpillar has eaten the leaf, it will be less than 20. Now if our caterpillar distance with the leaf is less than 20, we need to make a new leaf. So we are going to place a new leaf. It means previous leaf will be hidden and the new leaf will be visible to there. Now another thing comes up, that is caterpillar length. Now with this length, we need to increase the caterpillar length as per our game rules, because as many times as caterpillar eats the leaf, we need to increase the caterpillar length. You to make it difficult, you can even go for 1.5 or you can say 2, but we are just going to be keeping it to be much simple, that is 1 unit rule. Caterpillar will expand or length will increase for a single unit. Also take care that caterpillar speed increases and caterpillar speed will become from the previous value to +1. It means now our caterpillar will move faster than the previously, because now we have increased to 1 unit, so our caterpillar will be displaced to 3 units in just a single step. And forward condition is running on its own. We have entered that caterpillar will just keep moving whatever be the condition be, and we are not giving but user can control only the direction of the caterpillar. So we are going to make the functions for this. Take care that how direction will be controlled. Now another thing comes, as soon as your caterpillar length increases, you need to just resize your caterpillar. So here we are taking this shape size function, we'll copy it. Now we will resize it, reshape the caterpillar, because caterpillar shape will only be increased if we have not given it here. Then our caterpillar will only be reshaped when our game would have started again, and that is it would have started with the again the same, so no one would ever be able to notice that our caterpillar is increasing. So we need to resize again it. Now this was about the caterpillar size. Also we need to update the score variable. For our score was, you can take any score. To make it difficult you can take 5, and to make it easy you can take 20, but by default we are taking it to be 10. So 10 is a general number, decimal number, so every time your score will increase by 10 units. Also take care that you again call that function to display your score, because if you are not calling that function and not giving the parameter, your score will not be get updated. Now again comes the if statement, if outside window, and outside the window means we need to go for the game over, that the function that we have actually created, and come out of this loop. So here we go, we will add a break statement. This break statement will actually bring out of this loop, and our game was already over, so nothing would be visible. So we will be out of the game start and everything is over. Also you can see that first caterpillar will move forward direction, means as per the caterpillar speed. Its speed was 2 units, so it will move 2 units. After moving for 2 units, it will go check the if statement, that if it has eaten a leaf or not. If it has not eaten a leaf, it will check if it is outside the window or not. If it is not outside the window, then again it will come back and move. So you can feel that when your caterpillar moves in the game, the time was so short that it is very difficult for us, for a blinking of eyes, to notice that our caterpillar has moved, means the duration that it has moved. But our program just runs these statement in that particular interval of time, that is just in few milliseconds, and check all this condition. Again they move the caterpillar, again they check it. So what I wanted to tell you here, you can notice that how fast these codes or instructions are being written by the compilers to do that. Since it is not a much issue, since the speed of our processor will be more larger than 10 to the power 8 instructions. So if there would be 10 to the power 8 instructions per second, there are only a few statements, that is 10 statements, or yeah, 10 statements. But if there would be a 10 to the power 8 statements, it would have taken only 1 second for us to. But we will not go in that depth. Now this was about the start game. One more thing, we have not added the key. You should know that how does the key work. For example, in tkinter, actually we bind the key. If you have ever used this, here in the turtle, we are going to use this on key. So there are two varieties of on key. You would see, the one is the on key press and the other one is the on key release. On key press means once you have pressed, it will just keep working for n number of times until the another key is not pressed. And on key release, if you are just binding the key, means pressing this key again and again. You have pressed your up direction key or left direction key. So if you are keeping it pressed, it's working for that duration also. If you have pressed that for once, it will working for that duration also. Now we need to just give the function, that is start game. So this is the function that we have actually created, and now we are going to give the space for this. So this space is a keyboard for the have written. We need to just change game. Okay, so this was our function that we have created. Whenever someone will press a space key, it will just start running. As soon as our global variable game started becomes true, the if statement will go and nothing will happen to it. Game started will remain as true only. Now this will just keep running. All the variables will set, they will be for one time only. Means this process will happen for one time, and if someone has again started given the space, then it will go to the if game started and return back. It means that if you are playing just you are at 90 score units and now you have pressed a space bar, so it will go to the game start, and since game is already running, means it will return back to the game start function. So if you have called this game start function inside this while loop, you will not going to get it anything. It means that your game will just go on even if you have tried to start the game or restart the game. This was the reason why we have written a if statement here. It works a lot because if someone had pressed a spacebar, it would have again started the game. Up till now, we have made a function how we can actually start our game. Now the things comes, we have also given a key to start this. Now previously you would know that we were actually using the time sleep function, that it will sleep the time after every 4 to 5 seconds that we have given. Now we will give some additional feature like t.listen. This function will actually respond to the calls that every time the graphical this turtle function, that is the graphical page of the turtle, will be calling. It will take care of that, and t.main loop will just keep running the function again and again. It means it will be just went on running again and again infinite number of times. Also I have discussed with you, I will go here. Okay, yeah, here we have given a function that is this one, that is the t minus t window dot height, and told you that it would not look good that if we are having a leaf just on the border of the side, or it may just went outside the window also, like half leaf is there but half is outside. So instead of that, we have just taken an average, that is minus 200 to 200 height and width, where the leaf would actually be relocated. And now this is the time to just run our game. So here we go. Now I got the graphic turtle, and that is the page. This is the default heading of the page and the default icon. Now I am just going to press the space, and you can see our game is currently working. So it has shown us the game over. Our score is also here, and but the thing is, we cannot control the direction. We need to just do something to control that. So leaf is also every time is relocated again and again. It means every time we just get a different direction for the leaf. For example, this time was was there only in front of us, and previously it was somewhere else, so we got a 10 points here. Now just let's start building the function to give the move to our keys. Also, this was our score, and our score was possibly at x comma y. We have set the position of the x comma y so that it may show us the score there. And if you want to just change it, like for example, instead of -50 I can make it -25, so it may look somewhat nearer or far away from the page. Now this time I will try to run it, and it has actually went outside. So instead of -25 we will increase it and make it -75 will also be -75. Now I will try to run it, and this time you can see, okay, the score was now at a correct position. It was previously touching here, so this is the correct thing for the score. Now we will here today work on the move down feature, that how with the keys we can control it. So we need to make some keys here. Before making the functions, we will just make the keys. So let's start. First, our key will be, for example, I will remove this. Now one key will be for the move up. I am just giving here move up. So with this key, if I press this key, I should go or move up there. And now I am going to give the arrow key, that is up. Just don't press, if you try to press your arrow key, like if I try to press my arrow key, but it will not happen. So we need to give the correct function to call that key. So correct function to call your up arrow key is up. You need to write up up there. Now similarly we need to make another key, that is move down. After declaring our functions, we will just discuss how actually they will work. So here we go, move down, and this time we need a down key. So this is for the down. Now next key will be on key, and this will be move left. So here we go with the move left, and our key will be left key. This will be for the left key. And now again we go with the t dot on key, and this time one last is left, that is move right. So here we get the right key for moving it right. Okay, so we have the functions move up, down, left, right. Now just discuss about them, how they will actually work. For example, if this is my caterpillar, let's come here. Okay, if this is my caterpillar and it's here, so this is the face mouse of the caterpillar, let's take it 8, and this is the end of the caterpillar 0. Now similarly I will copy it and paste it here. This will be the mouth, and this time this will be the end. And now again we will go down. So I will make 8. Now write it. Okay, so I will keep it till here only. So now I will copy this. We are going to copy it and paste it here, and just change the direction. So we can take anything, like 0 can be the mouth, or this is for only understanding. So if 0 is the end and 8 is the mouth, so this is a caterpillar, means this is going in a positive x direction. It means if you can ask the caterpillar to go up, it can change the direction. A valid caterpillar means if it is a real caterpillar, it can change the direction. If you would ask your caterpillar to go down, it can change its direction. But if you ask the caterpillar to just move in the right direction, it is just moving in the right direction. Since forward is not in our control, so we can only give the direction to move, so nothing will happen. But if you ask the caterpillar to move in a negative direction, it is not possible for the caterpillar. Similarly, if this is the face and this time you ask the caterpillar to move in the right direction, it is not possible for the caterpillar. Our caterpillar cannot move in the reverse direction. We are taking this in a consideration. So the correct way to go in this direction, first is to caterpillar move down or left, then change the direction, and then it is possible to go to. Similarly, if caterpillar 8 is the mouth, if caterpillar is moving in up direction, it cannot go down, and if it is moving in down direction, it cannot go up, but it can go left and right this time. So what I wanted to say that we cannot have a reverse direction, and if someone tries to press the key, means if caterpillar is moving in this direction, user asks that okay, move in right direction again, so it should, nothing should happen there. So the total conclusion is our caterpillar cannot just reverse a direction if a reverse key is pressed. It's need to just change its route or path to reverse the direction. It cannot happen all of a sudden. Okay, so this was it. Now considering this, we are going to declare our functions. So our first function will be define move underscore up. Now why I have told you, the reason is the variable that I am using, if caterpillar dot heading. So now this dot heading actually gives us the direction, that to which direction our caterpillar is moving, and it gives us the direction in an angle. Means you can consider our screen to be a clock, and with that clock it will give you a direction. For example, if you are going up, it will give you 0 degree. If you are going downside, it will give you minus, you can say minus 270 degree, minus 180 degree for moving left. So it will give in a direction. Now what we need to take care, that if caterpillar is moving in a forward direction, or if a caterpillar is moving or heading, you can say that is the, as per our rules, that it cannot go reverse, means it can just move in an adjacent direction, perpendicular direction. If it is moving in vertical direction, it can change direction to horizontal. If it is moving horizontal direction, it can change direction to vertical. So since we are making a move up function, means 0, and this time the vertical direction that is left is 180. If it is moving in a horizontal direction, that is 0 degree or 180 degree, positive x or negative x axis, then only it will be able to caterpillar dot set heading. Now what this set heading will do, it will just change the direction of the caterpillar to 90 degree. Since we are using move up, so up means 90 degree, so it will change the direction of the set heading 90 degree. But if you are not, you are moving in other than these, like you are just moving upwards or going downwards and try to reverse the direction, that will not be possible for you. Now next thing comes is move underscore down. So what this move down function will do, if we will copy it from here only, paste it here. Okay, so this time if for caterpillar we are checking for moving down, so same, that is 0 and 180 degree. If our caterpillar is in horizontal direction, positive or negative does not matter, then only we will able to switch the direction. This time if we press the down key, we should go downwards, but the condition is that caterpillar should be moving in a horizontal direction. Now we are going to define move right. Here we go. Now I'm going to paste it. Now since we are talking about the horizontal direction, we should be on the, you can say we should be on the vertical direction, means 90 and 270. Otherwise we will not be able to switch the direction, because according to our condition, our caterpillar cannot reverse the direction. So since for right we need a positive 0, it is 0th angle, this is for the positive x-axis. This time we are going to just define move underscore left. So here we go. I am going to paste this, and it will be 90. Check it, it's 90, and this will be 270. So this is the condition for the vertical direction. If our caterpillar is moving in a vertical direction, positive or negative doesn't matter here, then only we will able to switch, and this time we are switching to 180. See, you can make it to be a reverse, but an caterpillar cannot just change a direction like humans, because it is a long one. So making it move in a reverse direction is, it will not look practical, and does not make any sense that caterpillar just start moving backward. So this is that's why we have limited our direction. Set heading is for changing the direction. Heading is just for checking the direction. So take care of these two. Now I am going to save it. We have added a listen and main loop. That is, this time we don't need a time function. So if you wanted to remove the library, you can remove that. Now I am pressing to start. So you can see I am able to control it. Now if I eat the leaf, so my score is getting updated, and my caterpillar is also getting elongated, plus the speed of the game is also increasing. You can see it is getting faster and faster every time. Okay, so game over is visible to us. Now our function working fine. We are just able to see everything. Okay, so there was a mistake. This score should be 4. That's why it has just given us the same score. We will save it and run it. Going to run it again and just check whether there is anything left or not to be changed. My score is getting updated. That's fine. Previously we have not entered the score variable, we have just entered the 10 there, and this is the reason. Yeah, so our score is 40 and it has shown as the game over. So our game is working fine. Congratulations, you have built your own caterpillar game using the graphical interface, that is Turtle. Also, we don't need this time the time library, so if you want you can remove it, and our project is completed. I hope you have enjoyed it. This was a really very practical game. It tells us many things about the Turtle library also and about the gaming also. So thank you for watching this video.